So section 5.3, today we're going to be solving trigonometric equations. And here just describes what we're going to be learning and why, if you're curious. Review. Find all the solutions, all of them between 0 to 2 pi, not including 2 pi. So we have something like cosine x equals negative square root of 3 over 2. So what you're doing is you're trying to solve for x. And to isolate x, you have to get rid of cosine. There's only one way of getting rid of cosine. It's the inverse, or arc cosine. So we do that to both sides of the equation. And that cancels out the cosines over here, and you get x equals cosine inverse of negative square root of 3 over 2. And then that was what you were doing for your review assignment that was due today. You were just finding where is cosine negative square root of 3 over 2. So if it's negative, what quadrants are we looking in?
What? 2.
2 and 3. Because this does say find all of them between 0 and 2 pi. So no restrictions. Well, right. This is the restriction given, is find all of them between 0 and 2 pi. So what degrees is cosine square root of 3 over 2? 30 degrees, so a pi over 6.
Yep.
So this is a pi over 6 reference angle. But remember, we're giving
2 pi or 5
pi over 6. So we're going to say x equals 5 pi over 6. And then what's our second answer? 7 pi over 6. And I'm writing my answers kind of the same way that we were writing them for our assignment yesterday, where we have a set notation, 2 answers, separated by a comma, in squiggly brackets. Then underneath that, it says now find all the solutions. So if I were to take off the restriction between 0 and 2 pi, if you were to find all of them, how many times could I go around that unit circle? Infinitely many. So to do that, we're going to do something that we had done in the last chapter, where we're going to add on something with a k. Remember that? Yeah. So our first answer would be x equals 5 pi over 6 plus, how much is it to go all the way around one time? 2 pi, but we could do it as many times as we want, so we're going to say 2k pi or 2 pi k. Well, yes, but we're not going to do it that much, so don't worry. And then, but that's only one of those answers. There were 2 answers, so also we would write and what was the other answer? 7 pi over 6 plus 2k pi, and I've already written where k is an integer. So there'd be 2 answers plus infinitely many versions of those answers. That'll be all the answers. Okay, second question. Cosecant x equals square root of 2. Now, you would do the inverse to both sides, but you don't have to write that step. If you know right now that I am finding an angle, I think you can just find the angle. You don't have to write cosecant negative 1 on both sides. Yeah, it would be like this.
Yeah.
But I'm not even going to write that step. I'm not going to write it. I'm just going to know that's what I'm doing. Now, you may not have cosecant memorized, and if you don't have cosecant memorized, we can look at it as being sine, but the reciprocal of. So I could also write this as square root of 2 over 2 by reciprocating square root of 2, making it 1 over square root of 2. So where is sine square root of 2 over 2?
45.
45. And this is positive. So it's going to be here and here. So So we've got x equals, what's 45 degree angle?
5 over 4.
Pi over 4 and 3 pi over 4. And to find infinitely many, I would do
Same thing.
the exact same thing, plus 2k pi. So I'd have both angles plus 2k pi. There you go. If it is a new question, you should. But don't worry, we're not going to do that. Okay. All right, and then third one, cotangent. I don't have cotangent memorized, so I change it to tangent. And I reciprocate that, so I get negative square root of 3. So where is tangent negative, and where is tangent square root of 3? It's negative in second and fourth, and it is a 60 degree.
Yeah, that's what I wrote, but.
So that will give me 2 pi over 3 and 5 pi over 3. All right, and then we do all the solutions. I'm not going to take time to fill that out. Questions?
Yep.
That was review.
Oh.
Okay, next is we're going to verify, which sounds a lot like what we were doing last week. Verify that the x values are a solution of the equation. Don't change the identity. Ooh, that sounds like what we were doing last week too. So verify means plug it in, show all the steps, but it says don't change the identity. That means that we're not going to move the 1 over. We're not going to divide by 2. We're not like actually solving anything. We're just going to plug in pi over 6 like this. Sine pi over 6 minus 1 equals 0. And then every step that we do, we're going to leave it equal 0 and just show this left side, we're going to make it equal 0. So we're doing what we were doing last week where you're doing the identities. You're keeping this side, or keeping the right side the same and making the left side look like 0. So I would start by saying, what sine of pi over 6?
So 30 is a half.
Sine of 30 is a half. So then 2 multiplied by half is 1, and that's 0 equals 0. Check. I have verified this, that is true. Okay, and then the next one, it says verify that it's true. So we're going to first plug in 2 cosine squared 4 times pi over 16 minus 1 equals 0. But I'm not going to take the 1 over. I'm just going to make the left side say 0. So order of operations is a little bit unclear because of where that squared symbol is. The squared is happening after you plug in your angle, so you're going to do this part first. We have 2 cosine squared of whatever that number is. Pi over 4 minus 1. Then what you have to do is you have to do cosine of pi over 4 next. It's the square that happens last, kind of in this case. It's just kind of, this is the weird way they set it up. But. So what's the cosine at pi over 4?
32 over 2.
Then we'll square that amount. That's after you find the cosine that you do the square. We get 2 times 2/4. And 2 times 2/4 is 1. So you get 0 equals. So you just have just a couple questions in your homework. We're going to verify that it really does work. Then the rest of your assignment is just like these, where we're going to solve. Today we're just doing solving. Tomorrow we will be factoring and solving. So remember how you did factoring practice. Tomorrow you're going to be doing it with this kind of stuff. So today we're just getting the solving part down. All right, so how do I solve for x? What should I do to both sides? I'm going to isolate x.
Add 1.
Subtract 1.
Yeah,
Yes.
subtract 1.
Okay, so we got 2 sine x equals negative 1. Then what?
Divide by 2.
Divide by 2. So I get sine x equals negative half. So now where is sine x equal to negative half? If you need the picture, it's negative, so sine is negative in third and fourth. And this is a what reference angle?
30.
The 30 degrees, so it's a pi over 6 reference.
So that one's going to be 7 pi over 6.
7 pi over 6 and 11 pi over 6. You want to put those in order, like they would go around the unit circle. Put them in order.
So it's basically like factoring an extra step.
Get,
Solving.
yeah, we're just solving with the extra step at this moment, yeah. Okay, next one. We've got 4 cosine squared x minus 3 equals 0. What should I do first?
Actually,
Add 3. So we have 4 cosine squared x equals 3. And what should we do?
Divide by 4.
Okay, divide by 4. Right there. So I've got cosine squared x equals 3/4. Now we square root, but there is a rule that says when you square root, you're going to get, I hear it,
Positive and negative.
you're going to get both a plus and a minus answer. So it's very important that you put those both there, or you're going to miss half of your answers. So I'm going to simplify this. This is going to give me cosine x, because I square rooted it. On the other side, I have plus minus. And when you square root a fraction, you square root the top and the bottom separately. So I get plus minus square root of 3 over 2. So where is cosine of x either positive square root of 3 over 2 or negative square root of 3 over 2? That's a pi over 6 reference angle,
30.
30 degrees reference angle. So here it would be positive, here it would be negative, here it would be negative, and here it would be positive. How many answers am I going to have?
4.
Right. So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay, so I asked you to have a computer or your phone so we can get on Desmos. I want to show you how you can possibly, when you're at home, check your answers to kind of make sure you're doing it right. And it is much more user-friendly on Desmos than on your graphing calculator. So I'm going to show you on Desmos. If you haven't gone to Desmos before, it's DESMOS, Desmos.com. DESMOS, then it's going to ask you like to start graphing. You're going to click on the start graphing button. Okay, and then we're going to type in, and I have it up there, we're going to type in 4 cosine squared x and then minus 30. There is a button. When you start typing, stuff comes up. And there's like an a squared that gives you the squared. And this function button over here is where you can find things like cosine and secant and cosecant and like the ones that are not as easy to write down. You can find those under that function button. So go ahead and type in that equation we were just working on.
Oh,
Yeah, I'm gonna start it over and do it. I have the graph there, but I'm gonna start it over. What's the first number? I didn't.
4.
Thank you. 4, and then it was cosine. And then you can put that squared in there. -3. So yours should look something like mine. And then this is very user friendly, especially if you have the computer, you can like drag it around, you can do what you want to it. But we're only looking at answers between 0 and 2 pi. So what is 2 pi?
6.28.
6.28. So what I'm looking for when I talk about answers, we're looking at x equals when the other side is 0. So I'm looking for the x-intercepts. If you click on them, they should pop up. A little easier to do on the computer than the phone, I think, but you can see there's 4 places that it crosses, and they are the answers that we have. So I don't want you to be like at home not knowing if you're doing it correctly. Like you can check your answers. You just can't do it on the test. So by then, hopefully you know you're doing it right. There's a way to change the x-axis so it looks like what we're using. If you go over to this little tool, and then it says for the x-axis, this step, if you type in pi divided by 2, then it changes that so it looks like what we've been used to seeing. I think Desmos is very user-friendly, especially for some of these you might want to make sure you're doing it right. Okay? So you can have that in front of you. Let's go through solving the rest of these, and if you want to check any of your answers or see any of the pictures, we can look at those too. Let's go through solving the rest of these so you know how to do it. Ready? Okay. We've got secant x multiplied by secant x minus 1. We have to solve for x. Now this kind of looks like what you're doing for your homework last night. Kind of. Where you've got, let's pretend that secant x, let's call it u. Wherever I see a secant x, I'm going to make it a u. So I could rewrite this as u multiplied by u minus 1 equals 0.
Oh, so it's x.
So what would I do if I were solving this one? I would say u equals 0 and u minus 1 equals 0. And then I would solve for u. But it's not u. It's secant x. So we're going to start out just the same way. We're going to say secant x equals 0. And we're going to say secant x minus 1 equals 0. Because it's already in like factored form. You set each factor equal to 0. That's what you did in your factored homework. It was already factored. You did it. Now we have to solve. So the first one, where is secant x equal to 0? Do you have your secants memorized?
Yep.
So what can we change this to?
Cosine.
If I change it to cosine, then I have to reciprocate 0.
Okay, so that's.
Where is cosine undefined? Here's the cosine graph-ish. I can draw it even more, but don't really need all of it. Remember, undefined are those asymptotes? So where is cosine undefined? Nowhere. This piece of secant x equals 0, that piece of the equation will give you no answer.
It's just like
Kind of, yeah. That part gives you no solution. But don't worry, we'll get a solution from the second part.
Cosine.
So it is possible to not have a solution on some of these. All right, well, I think everyone has an answer, but on parts of it, not have an answer. So the second part, secant x minus 1, that's going to be the same thing as secant x equals 1, which is the same thing as cosine x equals 1, because we reciprocate 1 and it's still 1. So where is cosine equal to 1?
0, 0.
0. And it would also be at 2 pi, but the directions say don't include 2 pi. Right? Nope, not 2 pi. 5 pi. Wait a minute. Now I'm yeah, just 2 pi. I was thinking there were also pi, but that would be -1. Never mind. So this is the only answer. Now, if you did graph it, you would see it's kind of funny looking. If you did graph secant x multiplied by secant x minus 1 on Desmos, you would see that it only hits at 0, and then again at 2 pi, and then again at 4 pi, and so on. I think I might have it crunched. I know I did when I was doing my notes. I don't know if I still do though. Okay, just do it. So I have functions, and I do secant x, and then parenthesis, secant x, and then minus 1. You can see that it's kind of weird looking, but it only hits at 0 and then not again until 2 pi. All right, almost done. Next example, what should we do first? Add 4, then divide by 3. Now what should we do? We're going to square root, but if I square root, I need plus minus. Okay, because I square rooted 4 over 3, which is the same thing as square root of 4 over square root of 3, which is 2 over radical 3. I'm not going to, because I don't want to use cosecant. I'm going to change it to sine. I mean, you can rationalize it, but then you're giving yourself more work. So I want to know where sine x is either positive or negative, and I'm going to flip it square root of 3 over 2. So where does that occur? Pi over 3. Yeah, at 60 degrees. And this is positive and negative, so there's all 4 of them. Picture-wise, it would be 60 degrees, then 120, then whatever that is. So we've got pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Last example. Last example is yeah. So this one is something that has already been factored. You don't want to FOIL it because you're going to make it more complicated. It's already in factor form. We're going to set each factor equal to 0. So you're going to have 3 cotangent squared x minus 1 equals 0. You're also going to have cotangent squared x minus 3 equals 0. And solve each one of these. So over here we'll have 3 cotangent squared x equals 1. So cotangent squared x equals a third square root. And we get plus minus square root of 3 over 3. Actually, I didn't need to rationalize that. I think I'm going to unrationalize it. Didn't really matter. Then on this one, same thing, solving. Okay, so once you get to here, I don't have my cotangents memorized, so I change them into tangent. So this one will become tangent x plus minus square root of 3. This one over here becomes tangent x equals plus minus square root of 3 over 3. Now what degrees is the one that has square root of 3 over 3?
It's 30.
That's the 30 degree one. This is the 60 degree one. Now I'm going to put these in order. So 30 is going to come first, but then it kind of gets a little more confusing. So if you need to draw a picture, we're going to have 30 degrees, then we're going to have 60 degrees, then we're going to have 60 degrees, then we're going to have 30 degrees. Then we're going to have 30 degrees, then 60, then 60, then 30. Like around the unit circle. We're going to have 8 answers. And if you graph it, you have the computer in front of you. If you graph it, you can see all 8 answers also. So we're going to have pi over 6, then pi over 3, then 2 pi over 3, then 5 pi over 6, 7 pi over 6, 4 pi over 3, 5 pi over 3, and then 11 pi over 6. I know. So I just did that by going around the unit circle. I'm a visual person, so I drew it so I could kind of figure out which one came first around the unit circle. If you had it graphed in Desmos, you could just look left to right, but don't rely on Desmos because you're not going to have it on a quiz or a test. Question? Okay. I do have it graphed somewhere here.
Does it look funny?
It kind of. Is it this one? Yeah. But there were 8 answers, so we've got 1, 2, 3, 4, 5, 6, 7, 8, all the way to 6.28. So at least we're not doing the graphing by hand, right? Okay, so that is all the notes. You guys have your assignment in front of you, and you have the rest of time to work on it and ask questions.